Hey everyone, it's Miss Marnon. So already you've been working with multiplication. Today we're going to start talking about division, and we're going to kind of relate the two using multiplicative inverse. So our objective today is I can change division to multiplication with multiplicative inverse. So for our DIN, for our review, it says use the numbers 2, 8, and 16 to write multiplication and division fact families in the first column. So here we have right here, you're going to write some fact families for multiplication with 2, 8, and 16, and then some with division. So pause the video and do that now. Okay, so we should have written some fact families for these numbers. So for multiplication, you might have written 2 times 8 equals 16, or you might have written 8 times 2 equals 16. For division, you could have had 16 divided by 2 equals 8, or you have 16 divided by 8 equals 2. So those are just some different fact families relating all the numbers. So now our preview says, what do you predict for the second column? Fill it in. So pause the video and fill in the second column. So there's actually a lot that we could fill in here. We already learned multiplication, so you could do this, but I'm going to start doing some negatives. So you could have done -2 times 8 is -16. You could have done 2 times -8 is -16. You could have done -2 times -8 is +16. Let's put some parentheses around this. So those are some of the things you could have done. We also already had all the positive ones. You could reverse the orders, and you could have a whole bunch because of commutative property. For division, you might assume it's going to look something similar. I'm not going to fill in this box just yet. I want you guys to come back to it and check how you filled it out based on what we learned in our notes. So I'm going to scroll down. So our notes, we have multiplicative inverse, the blank of a number such that you can blank them together to get blank. So if you have an idea of what to fill in the blanks, pause the video now and fill in each blank. Okay, so I'm going to tell you that this is the flip of a number such that you can multiply them together to get 1. So some examples, if you had 2 and 1/2. So if you multiply 2 and 1/2 together, you get 1. We could also have, let's see, I don't want to do one of these examples. We could have -1/4 and -4. So what we mean by flip is that you're flipping it. So we could also include 2/3 and 3/2. So like when you guys were dividing fractions in 5th and 6th grade and you guys said keep, change, flip, I'm talking about the flip of the number. So 2, it's really over a secret 1, right? And 4, -4 is also over a secret 1. When you flip it, comes the fraction 1/2, or and then when you flip -4 becomes -1/4. When you flip 2/3, it becomes 3/2. When you flip 3/2, it becomes 2/3. That's what we mean by the flip of a number. There is another word for this that I'm going to tell you. It's reciprocal. Reciprocal. Reciprocal just means the flip of the number. It stays positive or it stays negative. And we need that because when we multiply, we need it to be 1. So if you have a negative number, to get it to be +1, it needs to be multiplied by a negative number, right? We learned that in our 2 multiplication lessons. So here we have a table. They gave us an example. So if you have 3, the multiplicative inverse is 1/3. The proof is if you do 3 times a third, you get 1. And then you can use the multiplicative inverse. Instead of writing divide by 3, you can do times 1/3. We know that if I did 6 divided by 2, I get 3. But 6 times 1/2 is also 3. This is why we want to use the multiplicative inverse. Just like how we've been changing subtraction to addition, we can change division to multiplication. Multiplying is easier than dividing, So if we can multiply it by something instead, that kind of makes it easier. So right here, we changed 12 divided by 3 to times 1/3. So pause the video and see if you can fill out the rest of this table. Okay, so let's go through and write all of the multiplicative inverses first, just to make sure we have that part right. So if I'm going to flip this 5, it's really like it's a 5 over 1. So the multiplicative inverse is going to be 1/5. The same with a -2. It's like it's over a secret 1. So when we flip it, it's actually going to be -1/2. And when we flip this -3/5, we get -5/3. So if you need to check your multiplicative inverses before you move on, pause the video, check to make sure that you have the same multiplicative inverses as I do. Okay, let's go on to the proof portion. I think I'm actually going to extend this box a little bit if I can. Sometimes it lets me, sometimes it won't. Okay, I don't think it will. Maybe if I do a bunch of spaces. No, okay, never mind. So we're going to just multiply these together. So if I did 5 times 1/5, you can type it in your calculator or you can use your rules for multiplying fractions. This is the same as 5 over 1. You multiply straight across, so you get 5 over 5, which is equal to 1. Here we can do -2 times -1/2. Multiply negative times a negative is going to be a positive. That will be a +2 over 2 or +1. Now we can do -3/5 multiplied by -5/3. You're going to get negative or +15 over +15, right? Negative times a negative is positive. 15 over 15 is just 1. So now I'm going to actually change colors so we can see the difference when I go into that last box. So we need to rewrite this. Instead of dividing by 5, I want to multiply by the multiplicative inverse. So instead of dividing by 5, we can do 65 times 1/5. Instead of dividing by -2, we can do 18 times -1/2. Instead of dividing by -3/5, we can do 6 times -5/3. And that's really where your rule for dividing fractions comes from. It's from using the multiplicative inverse. That's what that flip means. That keep, change, flip, that changing to multiplication, and then the flipping of the fraction. This is where it comes from, is multiplicative inverse and using that reciprocal. So now that we can see that we can change division to multiplication, we can actually use it for these statements. So we have 28 divided by -7 is -4, because we can actually change this to 28 times -1/7. So I did that keep, change, flip that you guys did in 5th and 6th grade with fractions. I changed this to division to multiplication, and then I flipped it to the multiplicative inverse to -1/7. So because I know my rules for multiplication, means if I have positive times a negative, I get a negative answer. That is -4. So same thing here. We have -72 divided by 9. We can change it to multiplication because we learned the multiplication rules. So now that I know it's a negative times a positive, we know our answer is going to be negative. And 72 times 1/9 or divided by 9 is 8. So what we're doing right now is we're showing that because division and multiplication are related, they're going to have the same rules. So here we have -24 divided by -6 equals +4. And we know that because if we change this with the multiplicative inverse to multiply by -1/6, a negative times a negative is a positive. So we get +4. So just to reiterate, we're showing that because multiplicative inverse exists and multiplication and division are related, we have the same rules as multiplication. So same rules as multiplication. So let's look at the rules that we have here in our notes. So we know a positive times a positive is going to be a positive. A negative times a negative is going to be a positive. A positive times a negative is negative. And a negative times a positive is also negative. So when we change it, when we have a positive divided by a positive, that's still positive. A negative divided by a negative is also positive. Positive divided by a negative, negative, and a negative divided by a negative is negative. So those are the same rules that we learned before. You can use a calculator to do these. I don't think you would need a calculator. Most of these are numbers that you know how to multiply and divide. Just make sure that you are paying attention to the signs of the number, and if the sign you are getting in the calculator is making sense based on what you know about the rules of multiplying and dividing with integers. So you have some practice problems here. You're going to do it's a quotient. A quotient means divide, or a product, and a product is multiplication, right? Pay attention to these ones. We know that when we have fractions written like this really means divide. So like for G and H, that's negative 36 divided by negative 3, and H is negative 24 divided by 6. We also know that mathematicians are lazy, so sometimes we don't even write multiplication. We don't put anything at all. So know that that is multiplication. So you're going to go through and do these practice problems independently. So I'm not going to show the answers in the video. You're going to do these on your own. And then you have an exit ticket, and this is multiple choice. This one says, which of the following calculations would result in a positive result? So which of these is going to be positive? Pick one of them. Then you have your self-reflection. I can do it, or I need help doing it. So you're going to do the practice, the exit ticket, and the self-reflection independently now. Okay, if you paused it and you're coming back to this video, I hope you guys have a wonderful rest of your day.